Right? Okay, let's look at this question. This is the given probability, this is the cumulative distribution function for a continuous random variable x. Right? So, and the question for this question here, that from your lecture notes, that they require you to find the values of a and b first, right? The values of a and b first. Of course, if you want to find the value of a and b first, you must have an idea of the characteristic of the some properties, some special properties of cumulative distribution function, right? That you must, before you're doing this with looking at this example, you must look at the previous example, right, from your lecture notes, all right? So where I'm talking about the value before and after, all right? Okay, I just revised again. So if you look at this, right, -2, for the value of -2 you have 0, right? So when you substitute the -2 here, 2 minus 2, you will 0 over 12, you were still getting 0, right? Can you see the special thing or not? When you're getting 0 and substitute here, you're also getting 0. This is special only for cumulative, the capital letter fx, right? The cumulative. So this also apply for the value of 0, right? Just now, -2 you're getting 0, -2 you're also getting 0. So it means that when you substitute the value of 0 here, means that f0. Okay, when you want to find the value of 0, so 0, 2 plus 0, so you have 2 over 12, right? 2 over 12. So the value will be the same as the one after, before and after. They will be the same, right? They will be the same. Just now, in the previous video, I have explained about the curve, right? The graph of capital letter fx, where it's always continuous, right? It's always joining, okay? Means that they are joining. Means that this point and this point, they are actually coincide. Means that they are actually the same point, right? The same coordinate, right? The same coordinate here. Definitely the y value will be the same, right? The y value, because the y value here, when you put x, this is your y value, your fx. So when you put 0, you have 2 over 16. Okay, definitely if when you put 0 here, a plus with 0 over 6, you will have the same value. You will have the same value, right? So it means that from this, I can see that 2 over 12 is the same as a, right? This is 0. So which is a is equals to 2 over 12 is 1 over 6. Now I get my value of 1 over 6, right? I have know the value of 1 over 6, right? The a is 1 over 6. So I can also finding the value of b. I can also find the value of b by using the value of 4 here, right? By using the value of 4 here. So let's see. Very simple. Now you have already know the value of a is 1 over 6, right? So I'm going to replace the a 1 over 6 into the function first, right? Okay, let's see how to finding the value of b. Just now the a, I already know the value of a is 1 over 6, right? So I just replace the a with 1 over 6. To find the value of b, just now I find the value of a, right? I'm using the value of 0. I want to find the value of b, I can using the value of 4. The 4 here and the 4 here, right? So you substitute the 4 into the function first. So means that now to find b, I'm using f4, right? f4. So you just substitute, right? Even got equal or no equal doesn't matter, right? For cumulative. So because why? Sir, why there are no equal but you still can substitute here? I already tell you the graph is joining, right? The graph is joining. So means that they are actually sharing the same point, all right? So when you're putting the value of 4 here, right? Yeah, you're putting the value of 4 here. So 4 over 6, all right? 4 over 6. So means that 1 over 6 plus with 4 over 6, right? So it's the same as the value you put here is the same as the value when you put the 4 inside here. It's the same. Alright. So it means it's a b plus 4 over 12. So they are exactly the same. Means that the 4 you're putting here, the value that you get, and the 4 you're putting in, the value that you get will have the same value. Alright. So we're using this characteristic to find the value of b here. So 4 and 1, you're getting 5 over 6. And this will be, you can reduce this to 2 over 6, right? 2 over 6. 2 to 4, divide by 2, right? 2 divided by 2, you have 6. So it means that the b is taking 5 over 6, right? 5 over 6 minus with 2 over 6, right? 5 minus 2, you have 3 over 6, so you're getting 1 over 2. Finally, you have got your value of B by knowing the properties of the characteristic of the value before and after, right? So now I have known the value of B, and some students were asking me special a bit. They were asking me, sir, can I using 6 to find B? Can I using the value of 6 here to find B? Alright, alternatively, for this one, you can using the value of 6 also. You can use 4, you can use 6. This is also before and after, right? So when you put the value of 6 here, right? When you put the value of 6 here, let's say if you're using this value, alternatively. So you can also F6, alright, capital F6, you consider about the value of 6. If you put 6 here, right? B plus 6 over 12. It will be the same as the value here, the 6 here, which is 1, right? So if you equate these two, you solve this one, you will have 1 minus with 6 over 12 is 1 over 2, right? You will still getting 1 over 2, right? You are still getting the value of B is 1 over 2, alright? So I have already teach you how to find the value of AB by using these examples here, alright? Okay, now I'm going to use this question again to find the probability density function. Alright, let's see. Alright, okay, let's using, now I have already found the value of A, right? And I found the value of B. Alright, okay, let's see how I'm finding the probability density function from this cumulative distribution function. Alright, is by using differentiation. Interval by interval. So for the first interval, right, for x less than -2, so your probability density function, it's you differentiate the big fx at that interval, which is 0, right? You differentiate a 0, definitely you're getting 0, right? You're getting the value of 0. So now go for the second interval, right? Go for the second interval, which is this interval is -2, x less than 2. So same thing happen, you have to differentiate each of the interval, each of the function. So the function for this interval now is 1 over 12, 2 plus x, or I can rewrite it to be 2 over 12 plus with 1 over 12x. So, alright. Doesn't matter, don't need to simplify, because you differentiate a constant, right? You are getting 0. Differentiate this, you have 1 over 12, right? 1 over 12. So later on, the third interval, which will be 0, x less than 4. So your probability density function at this interval, you have to differentiate the cumulative function at this interval, which is 1 over 6 plus with 1 over 6x, or x over 6. So differentiating constant, we're getting 0. Differentiating 1 over 6x, you have 1 over 6. Alright? Okay, now go for the fourth interval. So 4 between 6. So your probability density function is you have to differentiate the cumulative distribution function at this time, which is 1 over 12, okay, 1 over 2 plus with 1 over 12x. Differentiating constant, 0. Differentiate 1 over 12x, you have 1 over 12. And finally, right, the fifth interval, so will be x greater or equal 6, which you have to differentiate the cumulative function, which is 1. So, and you're getting 0, right? So this is the method, right, of finding back your probability density length function. So from the big F to the small f. So and you have to summarize everything here. You have to summarize. So where for probability density function, there is a 0 here, which is they were writing as otherwise. Alright, otherwise. This is belong to this one. Belong to this one and this one, right? These two, that 0 will belong to otherwise, and all these I'm going to put them into one by one, right? This is 1 over 12 for the first one, which is for the interval -2x up to 2, right? And next, from 0 up to 4, from 0 up to 4. During this time, your function is 1 over 6, right? 1 over 6, and later 1 over 12 again, right? 1 over 12 again. This is for during 4x and less than 6. Alright, so I have transferred all this into the piecewise function, and this will be a probability density function. Alright, so if you check carefully, 1 over 12, 1 over 6, 1 over 12, right? All the interval must be corresponding interval is correct. Alright, 4 up to 6. Alright, but you must know how to, when you move from the cumulative to the density, you know there is differentiate. So when you go in here, there is a long process that you must view the video for finding the cumulative distribution function. Right? For the same video here, I also going to show you how to find the how to sketch the graph. Okay, to sketch the graph, and okay, I will sketch the graph for you. All right, sketch the graph for the big fx. Right, I'm going to sketching both graph for you so that you can see the difference between cumulative and probability density function. Okay, at first I was sketching this. Okay, I was sketching this. So okay, I just roughly sketch so that you know the big fx, and it start with -2, right? -2 up to 6, right? So -1, -2. So 1, 2, 3, 4, 5, 6. Right? So the boundary value is -2 up to 0, and 0 up to 4, right? 1, 2, 3, 4. So 4 and 6, right? So I'm going to sketch the difference between these two graphs. Okay, there is a difference. So you see, when you substitute -2, right? This is all the straight line only, right? -2. So you have -2. Before -2, there is an empty circle here, right? There is empty circle here. So less than is 0, right? Fx is 0. Fx is 0 means, okay, it's a horizontal line. So when this is a straight line, this is a straight line. So you can just choose this value here. Substitute -2, you have 0. Suppose it have to be an empty circle, right? That's why the value before and the value after, they have the same value, because you see -2 you have 0, right? It must empty circle not included, but when you put the -2 here, you're getting 0 also, so means they are actually sharing the same point. That's why they have the same value here. Alright, so when you're putting the 0 here, 0, 1 over 6, right? You're putting 0, you have 1 over 6, so you have 1 over 6. During 0 you have 1 over 6. It's supposed to be an empty circle here. I always mention about this. There is an empty circle here, right? Empty, because there are no equal here, right? But when you put the 0, when you want to sketching this line, okay, you're sketching this line first, okay? You're sketching this. This is a straight line, right? This is the name for this line. So now, if you put the 0 here, if you putting the 0 here, right? Equal. So you are still getting 1 over 6, even though here do not accept, right? But definitely you are still getting 1 over 6. Means that the value for this and after is the same, right? You see that they are continuous. They are continuously berterusan, okay? Tanpa ada lubang, alright? No hole here. So now later on, if you see that now it's between from 0 up to 4. So when you put the 0 here, you're getting 1 over 6, right? So if you put 4, so you're getting 4 over 6 plus 1 over 6, you're getting 5 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, right? You have 5 over 6. So it means that during 4, you have reached 5 over 6. It's a straight line. It's a straight line, right? Here is an empty hole here because it cannot include 4, right? But later on, with this 4, you put inside here 4 over 12. 4 over 12 is 1 over 3, right? 1 over 3. So you add up 1 over 2 and 1 over 3, you're getting 5 over 6. And it will be still the same. It will be filled up, right? Akan diisi semula, right? Okay. Now, look for the last value. It's a straight line, right? 4. Now you're putting the 6 here, right? You're putting the 6 here. So 6 over 12. 6 over 12 is 1 over 2. 1 over 2, 1 over 2 is 1. But not included, right? Not included. So means finally it's 6 over 6. 6 over 6 is actually 1, right? 1. So means finally it will reaching 1. So during 6 it will be 1. but there is an empty circle here, right? It's a straight line, right? It's a straight line, right? But later on, 6 and beyond, right? 6 and beyond is 1, right? So it means that 6 and later is 1, right? You see the graph is keep increasing. This you try to see the difference later, right? The graph is like maniac, you know, in maniac, because this is a cumulative graph, cumulative distribution graph. The graph, of course, will be increasing, will be keep increasing. The most important thing, you must be able to see that they are actually joining, joining without any hole, all right? The other lubang, because why? That's why you see the value here is the same. Okay, the same. The value here is the same. Okay, you put 4 here and you put 4 here, the value will be the same because they share the same point here. That's why just now when I finding the value of A and B, I using the characteristic here. Okay, so now I'm going to sketch for you. And one more thing is you must see it start with 0, it end with 1. Alright, okay, now I'm going to sketch the small fx here. It's different, right? It's different. So the small fx is, okay, your small fx. So then you see that it's -2, same thing also, right? It's -2 to 0, right? -2 to 0, I'm using the same, the axis, but now this is a small letter fx, all right? This is a big letter fx. So there's a -2, right? -2, 0, followed by 4, 1, 2, 3, 4, 5, 6, right? So from -2 up to 0. From -2 up to 0, right? So it's 1 over 12, right? 1 over 12. So 1 over 12. So you know this is 1 over 12. I just write properly 1 over 12. So if you see that the curve here, they were actually a straight line, right? It's a straight line. So it's a straight line. It's a horizontal line because it's a constant, right? 1 over 12. So later on, if you look at from 0 up to 4, 0 up to 4 is 1 over 6. 1 over 6 is double of 1 over 12, right? Because 1 over 6 is actually 2 over 12, right? 2 over 12. So it means somewhere around here, okay? 2 over 12 or 1 over 6, right? 1 over 6 is from 0 up to 4. So during this time, it will be 0 up to 4, right? It's a horizontal line. Okay, later on, 4 up to 6, right? 4 up to 6 is 1 over 12 again, right? 1 over 12 again. So 1 over 12 again. Then you look at, there is a difference between these two, right? The small fx is not continuous. You see that there is a jump here, right? There is a jump here. So this one is no. It's like continue, right? This one is like jumping, you know. Wait here, you need to jump, right? There is a discontinuity here, all right? So for small fx, that may be discontinuous, all right? But the area I have teach you at the start when I'm teaching about the continuous random variable, I have mentioned about the area under the graph, right? The area under the graph for the fx, the probability density function is 1. You try, if you want, you try, all right? You say this is a 2, right? 2 times with 12 is this, which will giving you the area of 1 over 6, right? And this one will give you an area of 4 over 6, right? Because you take 4 multiply with the height is 1 over 6 here, the rectangle here. So it's 4 over 6 plus with 1 over 6 here. You already have 5 over 6, right? So now you look at this. This one is 2, right? 2 times with 1 over 12, right? You are getting 1 over 6 also. 1 over 6 plus 4 over 6 plus 1 over 6. You are getting total up 1, the probability, all right? It will be 1, right? And you look at this, right? This will be different, right? This is in the particular point, right? When 4, so the cumulative here will be 5 over 6, right? So I'm not going to explain this in more detail. I hope you do some research about this area here, all right? If you want to know further. So that's the difference between these two graphs, all right? For capital F, it's continuous, all right? They're continuous. And the value before and after is the same because they share the same point. But for this, no, they're not the value the same. Negative 2, the 0 here is 1 over 12, the 0 here is 1 over 6. Can you see that? So that's the difference, alright? That's the difference. When the capital fx, before and after, they are the same value. But for small fx, no, they are not the same. So it's 1 over 12, and this one is 1 over 6. When this is 4, this is 1 over 6. When the 4 here is 1 over 12. It's different, right? It's different. So you better make it clear, alright, so that you won't confuse here. So that's all for this video. I just want to teach you how to find the value of AB, and later on I teach you how to find the property density function from the cumulative distribution function, and the difference between the graph of these two cumulative and probability density function. Alright, hope you understand.